Here at Highlands, we challenge the exploration team to go out and find a naturally occurring source of nitrogen. We've been asked the question, why nitrogen? Why now? The price of naturally occurring nitrogen is significantly higher than the price of natural gas. We looked around pipeline infrastructure, we looked around manufacturing, we looked around agricultural purposes and food processing purposes. And we found what could be an ideal spot for not only producing, but distributing naturally occurring nitrogen.
Nitrogen exists in the ground as a gas, but we're not really sure why. One thing we've recognized at Highlands is that the occurrence of nitrogen often is associated in and around salt deposits. And I've struggled with this relationship for many years. And one day I looked at some salt, the largest crystals I could find, and I saw holes in them. And those holes we call fluid inclusions. And nature hates a vacuum, so there are substances within these inclusions. And it turns out that oftentimes the substance within a salt fluid inclusion is nitrogen. We believe that this relationship is clear between nitrogen and salt cemented sandstone. And in fact, the sandstone may hold an enormous resource of naturally occurring nitrogen. Nitrogen does in fact have value if it's pure compositionally and oxygen-free, and if it's located near an industrial use. Some examples include ammonia synthesis, and also oil and gas uses nitrogen, which is generally very costly, sometimes 3 to 4 times the price of natural gas.
Well, ammonia is a combination of nitrogen and hydrogen. And so the net result is, in the process, is you take the nitrogen and the hydrogen and you burn it, or you catalytically process it to ammonia, NH3. That's the easy part. It's an exothermic reaction, produces extra energy. The problem is getting pure nitrogen and pure hydrogen. To get nitrogen, it's 79% of air is nitrogen. You can either do an air separation plant. There's a lot of heating and large piping for this mole sieve dehydration and CO2 removal. Then the air is cooled so that you liquefy the components and then you separate the liquids. So again, a very energy intensive process. If you had the ability to have nitrogen and hydrogen in large quantities and a good quality, then you skip all of the processes necessary to get to that final step. When you look at an ammonia plant, the very last part of it is where you actually produce ammonia. Most of it is trying to get to those pure feedstocks. And so it greatly reduces the equipment required, greatly reduces the energy required. It's a very difficult industrial process, and you take it back to what the chemists were doing in their laboratory when they first developed this process.
So some of the challenges with nitrogen, one, it's good to have a pure product go into the well. You want to avoid having any oxygen going into wells for 2 reasons. One is it can corrode the steel pipes that we put in to create the wells. It can also cause bacteria to form in the reservoir, which is bad. Bacteria can have byproducts that we don't want, like hydrogen sulfide, which is a very dangerous gas. There's also scaling issues and other production issues that can happen when you have bacteria form.
There are multiple beneficial uses for nitrogen. We could inject nitrogen into a partially saturated aquifer that contains natural gas, and by creating a bubble, if you will, in the aquifer, we would collect and coalesce what is now a discontinuous gas phase within the reservoir, combine it to one single phase, and flow back a mixed composition of gases, including the nitrogen which we've injected and the recovered helium concentration.
We're on location here north of Coolidge, Kansas, doing this test well to determine the exact composition of the nitrogen. We want to get accurate third-party test results to make sure that this nitrogen is as pure as we want it.
Since the discovery of 99.5% pure nitrogen, the market has opened up and has broadened. to food processing, manufacturing, agriculture. We're looking into so many different markets. The possibilities are endless.